Hi guys, today we are going to talk about dividing rational expressions. So today we are going to look at the problem, quantity x plus 2 squared divided by the quantity 3x plus 9 divided by the quantity x squared minus 4 over the quantity 9x squared plus 27x. So something we can remember is that to divide rationals, we can turn this into a multiplication problem by multiplying by the reciprocal. So we can rewrite this problem as the quantity x plus 2 squared over the quantity 3x plus 9 times the quantity 9x squared plus 27x over the quantity x squared minus 4. So we want to see if we can reduce anything or cancel anything out. So we want to start by rewriting all of our numerators and denominators in factored form. In this case, our first numerator, we can expand out into x plus 2 times x plus 2. Our denominator, since there is no x squared term, we do not need to use the generic rectangle to factor this. However, we want to look to see if there is a greatest common factor in either of the terms. So for the 3x plus 9, we can see that there is a 3 in common. So we can factor a 3 out, leaving us with 3 times the quantity x plus 3. For our second rational, we can look in the numerator, and 9x squared plus 27x will have a greatest common factor of 9x. So we can factor out a 9x, leaving us with 9x times the quantity x plus 3. And then finally we can look at the denominator, x squared minus 4. In this case, we're going to have to use a generic rectangle and a diamond problem to help us factor this out. So remember, with the generic rectangle, we are going to put our x squared term and our constant diagonally in the box. So we'll have our x squared and our minus 4. And then we can set up our diamond problem. So we're going to multiply this x squared and negative 4 to get negative 4x squared in the top of our diamond. Because we do not have an x term in our problem, we'll need to find two terms that are going to add to 0x. So now we need to find two terms that multiply to the top and add to the bottom. In this case, we will have a positive 2x and a negative 2x. We can then take these terms and fill in our blanks in our generic rectangle. And now we need to find what multiplies to the inside. So I like to start with the x squared term first, and I know that x times x will multiply to x squared. We can then see that x times a positive 2 will multiply to 2x, and x times a negative 2 will multiply to a negative 2x. We can also double check that 2 times negative 2 will give us this negative 4. So when we factor out x squared minus 4, we will get x plus 2 times the quantity x minus 2. When writing this out in factored form, I like to factor everything as much as possible to see everything that can cancel out. So for example, this 9, I can rewrite that as 3 times 3. So when doing that, I then end up with the quantity x plus 2 times the quantity x plus 2 over 3 times the quantity x plus 3. And I'm multiplying by 3 times 3 times x times the quantity x plus 3 over the quantity x plus 2 times the quantity x minus 2. Now when looking at this, I want to look for everything that I can reduce or cross-reduce to create giant ones. So what I notice is I have an x plus 2 in the numerator of our first term and an x plus 2 in the denominator of our second term. So I can cancel these out because they make a giant one. I also notice that I have an x plus 3 in the numerator of the second term and an x plus 3 in the denominator of the first term, which will also cancel and create a giant one. And then finally I see that I have a 3 in the numerator of the second term and a 3 in the denominator of the first term, which will also cancel and create a giant one. So now we can actually multiply our two rationals, numerator to numerator and denominator to denominator. So in doing this, on the numerator I see that I have a 1 times the quantity x plus 2 times another 1 times 3 times x times another 1. And remember, when we multiply by 1, we're really multiplying by itself. So in this case, my numerator is going to be 3x times the quantity x plus 2. And in my denominator, I have 1 times 1 times 1 times the quantity x minus 2. So I will be left with the quantity x minus 2 in the denominator. We just want to double check to make sure that nothing will simplify to create a giant 1. And so we have a 3x in the numerator, which we do not have in the denominator, so we cannot cancel out the 3 nor the x. We also have an x plus 2 in the numerator, but an x minus 2 in the denominator. So since those are different, we cannot simplify or cancel out any of those terms. So now we can leave it like this, or we can distribute that 3x and rewrite it as simplified as possible. So 3x times x would give us 3x squared. 3x times 2 will give us a 6x. And then our denominator will just be left as x minus 2. Alright, so now we need to figure out what x values cannot be defined in our final simplified rational due to the fact that we cannot divide by 0. So we're going to look up here where we have rewritten it in multiplication form with all of the denominators factored and figure out what values of x would make our denominator equal to 0. So in our first one, we have 3 times the quantity x plus 3. Since 3 is already a number, we will never be able to make that equal to 0, so we'll move on to the x plus 3 part. If we set x plus 3 equal to 0, we can see that x will not be able to equal negative 3. If we look at our second rational expression, we have the quantity x plus 2 as well as x minus 2. So if we set both of those equal to 0, we'll see that x can also not equal negative 2 nor positive 2.